2.83 billion euros. 5 years of construction. An opening set for October 2011. Berlin Brandenburg Airport finally opens on October 31, 2020. 9 years late. The construction bill reaches about 6.5 billion euros. More than 20,000 defects are found in the fire detection and emergency lighting systems alone. The runways are ready. The terminal is standing. The trains can reach the station. For years, the doors stay locked. The story begins with a divided airport system. After German reunification, Berlin still depends on infrastructure built for another city and another era. Tegel handles traffic in the northwest. Schönefeld operates southeast of the city. Tempelhof remains close to the center. Aircraft, crews, maintenance equipment, baggage teams, and passengers are split across separate sites. In 1996, Berlin, Brandenburg, and the federal government choose one solution. Expand Schönefeld. Build one central airport. Close Tegel and Tempelhof. The new gateway will carry the name Berlin Brandenburg International. Later, the code becomes BER. The promise is simple. One terminal complex, 2 parallel runways, rail below the building, road above it. Domestic, European, and long-haul traffic in one place. Tempelhof closes in October 2008. Tegel stays open because BER is not ready. Passenger traffic keeps growing while the replacement airport moves through construction. By 2019, Tegel alone handles 24.2 million passengers. Every extra year at BER means another year of operating old terminals, maintaining duplicate systems, and postponing the final transfer. Planning runs through the late 1990s and early 2000s. Land is cleared. Villages are relocated. Courts review flight paths, noise rules, and nighttime operations. The financing concept is approved in 2004. Ground breaks on September 5, 2006. The airport is supposed to open 5 years later. The budget sits at 2.83 billion euros by 2009. A banking group provides the debt. The public shareholders guarantee it. Workers drive piles for the underground railway station. They pour retaining walls beside an airport that is still operating. Trains will arrive directly beneath the new terminal. Above them, baggage belts, check-in halls, security lanes, retail floors, departure gates, and smoke control systems must occupy the same structure. Every service crosses another service. Power beside data. Sprinklers beside ventilation. Baggage conveyors beneath passenger floors. Thousands of interfaces inside one building. The terminal contract is not handed to one general contractor. The main tender is cancelled. Construction is divided into individual packages. By early 2009, the passenger terminal is broken into roughly 35 lots. One company installs part of the ventilation. Another supplies fire detection. Another handles doors. Another runs cabling. Another supervises a separate package. The airport company sits above them, while the general planning team coordinates design and site supervision. On paper, separate contracts give the owner more control. Each package can be priced and awarded independently. On the floor, every opening, cable tray, duct, wall, and control signal now depends on several contracts meeting at the same point. Workers raise the concrete frame. The terminal begins to take shape in 2008. A long central hall faces the apron. Piers extend toward the aircraft stands. Passenger bridges connect steel and glass to the gates. Below the terminal, crews install railway platforms and technical rooms. Outside, earth movers prepare taxiways and the new southern runway. The old Schönefeld site remains active beside the work. Airport construction cannot spread freely. Security fences, live aircraft movements, roads, and operating buildings compress the site. By May 2010, the terminal reaches its topping out ceremony. The roof is closed. The glass facade is in place. The southern runway is approaching completion. The project still looks like an airport entering its final year. Then federal police requirements force the security screening area to expand. More lanes need more floor space, more equipment, more power, and new passenger routes. A change made near the entrance reaches technical rooms deep inside the building. The opening moves 7 months before the fire system has even reached final acceptance testing. Then the design keeps moving. Security rules change. The screening area needs more space. Retail plans change. Airline requirements change. Rooms move. Walls move. Technical services must follow. One order to enlarge a passenger zone shifts doors, cable routes, ventilation ducts, detectors, signs, and escape paths. Bosch later reports more than 300 change requests affecting its work. The architect says hundreds of owner-requested changes enter the terminal design before the general planner is dismissed. Management orders a stop to further changes in January 2010. Changes continue. Workers reopen finished ceilings. They reroute cable trays around new ducts. A hole drilled for one service meets steel installed for another. Drawings arrive after crews have already built the space. The terminal grows while the systems inside it are still being designed. The first opening date slips from October 30, 2011 to June 3, 2012. 7 more months. The official reasons include delays in technical building equipment and the expansion of security screening. Trial operations begin. Volunteers check in. Bags move through conveyors. Staff rehearse boarding and arrivals. Airlines plan the transfer from Tegel and Schönfeld. Shops prepare stock. Road signs wait for new destinations. The terminal appears finished from the passenger side. Counters stand in rows. Screens hang above them. Gates face parked aircraft. The unfinished work sits behind walls and above ceilings. Fire protection decides whether the building can open. In a terminal this large, a fire alarm does not only ring a bell. A detector identifies a zone. Control software reads the signal. Fire doors close to contain smoke. Other doors release for evacuation. Ventilation dampers change position. Extraction fans start. Fresh air systems pressurize escape routes. Elevators move to safe floors. Sprinklers activate in the correct area. Emergency lights and signs guide thousands of people through a building they may have entered only minutes earlier. Each action must happen in the right order. One false command can move smoke toward an occupied hall. One locked door can block an escape route. One missing signal can leave a fire compartment open. Acceptance testing does not ask whether each fan can spin or each door can close. It asks whether the entire chain responds correctly under hundreds of possible fire scenarios. A detector in one retail zone requires a different sequence from a detector beside a railway access shaft. The software must know the difference. The building must prove it. At BER, parts of this chain come from 5 different firms. The components exist. The integrated system does not work as one approved machine. The fire safety design, the building permit, and the construction on site no longer match. Smoke extraction is especially difficult. The system has grown with the terminal. Controls have been changed and reprogrammed. Air supply and extraction must balance across large connected spaces. Computer-guided fire doors must respond to the same logic. Interface tests expose conflicts between equipment, software, and the building around them. Workers watch test panels. A detector triggers. Some commands arrive, others do not. The sequence stops. By December 2011, the airport company is considering a fallback. Instead of relying on fully automated smoke control and computer-guided doors, people could operate parts of the system manually. The plan grows to as many as 200 people per shift. Human fire spotters would stand across the terminal and carry out commands that the automation cannot complete reliably. The building authority questions the approach. A modern international airport cannot receive final approval with its core life safety system replaced by hundreds of temporary operators. The fallback is shelved. April 20th, 2012. The Supervisory Board still receives assurances that June 3rd can be achieved. Invitations are prepared for an opening event with thousands of guests. Airlines arrange schedules. Equipment waits to move. 17 days later, the position changes. May 7th. The chairman is told that postponement is necessary. May 8th. 27 days before opening, the airport cancels the date. Completion, acceptance testing, and approval of the fire systems cannot be finished. There is no small correction left. The building has failed the test required to admit passengers. The next date is March 17, 2013. The airport company dismisses the general planner and construction supervisor. The technical managing director leaves. The decision removes the team that holds much of the integrated design knowledge. Subcontractors remain. Packages remain. Thousands of drawings remain. The central coordinator does not. Reconstruction slows for months. Workers arrive at completed rooms and wait for approved plans. Some systems cannot be changed until another system is mapped. Some ceilings cannot be opened until the services above them are identified. The attempt to accelerate completion creates a standstill. A new technical director reviews the project in 2012. The findings add 1.2 billion euros in capital needs. The breakdown shows how delay becomes physical cost. 276 million euros for additional construction already identified. 67 million euros for construction costs caused by the postponed opening. 230 million euros for additional operating costs. 322 million euros for risks and lost revenue. 305 million euros for extra noise protection measures. The total remains 1.2 billion euros after later reallocations. The new opening date moves to October 27, 2013. The review also finds no coherent integrated plan for finishing the terminal. Fire safety experts identify deviations between the approved concept, the planning permission, and the airport as built. The fresh air supply during a fire remains unresolved. The system is too complex to approve in its current form. On January 7, 2013, the October opening is cancelled. No replacement date. The airport is now a complete public building without permission to operate as an airport. The visible structure requires constant care. Rain reaches roofs and drains. Frost enters exterior systems. Pumps need exercise. Batteries discharge. Filters age. Lamps fail. Software becomes obsolete. Equipment warranties expire before passengers use the machines. Workers inspect rooms that should be full of travelers. They run conveyors with test baggage. They open access panels above empty corridors. Dust returns after every repair. A building designed to operate every day is being preserved in standby. The cable system becomes one of the largest repair jobs. Around 3,600 kilometers of cable run through the terminal. Power, fire detection, data, communications, access control, lighting, baggage handling, ventilation, and emergency systems share crowded routes. Some cable channels are overloaded and disorganized. Documentation does not always match installation. Before engineers can redesign the controls, crews must identify what is already there. Workers trace cables room by room. One end disappears into a tray. The other emerges behind a panel hundreds of meters away. Every line must be labeled, checked, and compared with the drawings. Only then can it stay, move, or be removed. The smoke control concept is divided into smaller parts. The largest extraction system, known as System 14, is split into 3 systems. A higher-level safety programmable controller is added. The goal is not to invent a new airport. The goal is to reduce one oversized control problem into sections that can be tested and approved. Each section must prove that detectors, fans, dampers, doors, emergency lighting, and alarms work together. Then the sections must work together without creating a new conflict. Workers remove installations that were already paid for. They cut out cable. They replace control cabinets. They reopen walls. They install new lines through spaces filled by the old ones. Every correction creates another inspection. Every inspection creates another list. Thousands of deficiencies remain across fire detection, emergency lighting, doors, cabling, ventilation, and documentation. The German federal government later states that more than 20,000 defects are identified in fire detection and emergency lighting alone. The terminal is not one failed machine. It is tens of thousands of small items preventing one certificate. Most of the airport outside the terminal works. The new southern runway is ready in 2011. Fire stations, winter service buildings, and waste facilities gain approval. By 2014, 39 of 40 buildings on the site have been accepted. The one missing approval belongs to the passenger terminal. Aircraft can land, fire engines can move, snowplows have a haul. Cargo operations begin in 2013. The building that connects passengers to the aircraft remains closed. Management changes continue. New directors arrive. New schedules are tested. A partial opening of the North Pier is considered. A fast-track program is launched. The plans do not produce an operating terminal. In 2014, officials point toward the second half of 2017. In January 2017, that target is abandoned. Another building permit is required. Doors, smoke systems, and control logic still need completion. December 2017 brings a new fixed date, October 2020. This time, the schedule includes 24 months of operational readiness work before opening. The money rises with every year. The original €2.83 billion budget has already become roughly €4.3 billion by late 2012. Continued redesign, maintenance, financing, noise protection, and operating costs push the construction total to about €6.5 billion, more than double the 2009 budget. The cost is not only concrete and steel. Tegel and Schönefeld must remain open longer. Staff, security, utilities, maintenance, and transport continue at the old airports, while BER consumes money without passenger revenue. Shops inside the new terminal cannot trade. Landing fees do not arrive. Debt still carries interest. The comparison is visible in Beijing. Construction of Daxing International Airport begins in late 2014. Its first phase includes a 700,000 square meter terminal and 4 runways. It opens in September 2019, less than 5 years. BER breaks ground in 2006 and opens in 2020, 14 years. Daxing builds one of the largest terminal structures on Earth during the period when Berlin is still tracing cable and retesting fire doors. By 2018, the BER terminal finally moves from redesign toward completion. Permits are added. Systems are tested in combinations rather than as isolated parts. One detector, then one zone, then one building section. Impact tests verify that a command produces the required physical action. Composite tests verify that connected systems respond together. Workers run the sequence again. Alarm, door, fan, damper, light, message, reset, repeat. Failed items return to the list. A second terminal is built beside the first. Terminal 2 uses a general contractor and reaches completion in September 2020. The contrast sits a few meters away. A simpler building. A clearer delivery structure. A defined package. Terminal 1 still carries the layers of decisions made since 2006. Old equipment beside replacements. Original drawings beside revisions. Finished architecture above reopened technical spaces. April 28, 2020. The local building authority confirms completion of Terminal 1 and releases it for use. The airport now has the document missing for 8 years. Testing continues. The pandemic reduces the planned operational trials, but the airport still runs 47 trial days. More than 24,000 employees and 9,897 volunteers take part. They process 179,000 pieces of test baggage and simulate 2,350 flights. Workers load bags that will never leave the ground. Staff send volunteers through security, boarding, arrivals, and baggage reclaim. The terminal finally behaves like an airport. At the end of August, the fire protection and evacuation exercise succeeds. Terminal 2 is complete in September, but remains closed because air traffic has collapsed. In 2019, Tegel and Schönefeld handled 35.65 million passengers. In parts of 2020, fewer than 1,000 passengers a day use Berlin's airports. The airport planned for crowded halls is ready during the quietest year in modern aviation. October 25, 2020. The railway station beneath Terminals 1 and 2 opens. During the night, booking systems replace the old Schönefeld code, SXF, with BER. October 31st. An EasyJet Airbus and a Lufthansa Airbus land on the northern runway. The first passengers enter Terminal 1. The ceremony is small. One day later, the first departure leaves for London Gatwick. November 4th. The southern runway enters service. November 8th. Air France Flight 1235 leaves Tegel for Paris. Berlin's air traffic moves to the airport selected in 1996. The building opens, but the financial work continues. The pandemic removes the passenger volume expected to support the debt. Only 213,000 passengers use BR in its first full month. Terminal 5 closes in February 2021. Terminal 2 waits until March 2022 to begin operations. In 2022, the European Commission approves up to €1.7 billion to recapitalize the airport company after pandemic losses. The aid is separate from the original construction bill, but it reaches the same public company carrying debt from the delayed project. BR now operates every day. The terminal that could not pass a fire test handles millions of passengers. In 2025, 26.1 million travelers pass through the airport. More than 193,000 aircraft take off and land. Revenue reaches €666.5 million. Operating earnings before interest, taxes, depreciation, and amortization reach €203.9 million. The company still records a net loss of €86.1 million, but the number is falling. In February 2026, the shareholders make a final €500 million capital injection under the agreed debt reduction plan. The airport company says it is no longer dependent on shareholder guarantees. The systems finally perform the sequence designed years earlier. Bags enter the conveyors. Detectors report to the control room. Doors release and close on command. Trains stop beneath the check-in hall. Aircraft use 2 runways. Workers maintain equipment that once sat behind locked doors. The airport functions. The construction history remains in the balance sheet. The replaced cable, the revised control cabinets, and the 9 missing years. €2.83 billion became about €6.5 billion. October 2011 became October 2020. 35 terminal packages, around 3,600 kilometers of cable, more than 20,000 defects in 2 safety systems alone. 14 years from groundbreaking to opening. One airport finally carrying passengers. Subscribe for more engineering stories.